Catalysts and enzymes. Catalysts speed up chemical reactions. They do this by lowering the activation energy of the reaction. Less energy is needed to start the reaction, so it happens more quickly. The catalyst remains unchanged. The initial and final energy of the reactants and products is not changed by the catalyst.
Catalysts work by decreasing the activation energy. Just as a rock cannot quickly be pushed over a hill, a reaction cannot quickly occur unless the molecules possess sufficient energy, the activation energy. If the height of the hill were lower, the person could roll the stones over the hill at a faster rate. Catalysts speed up reactions by reducing the activation energy for the reaction.
Life requires energy. Living things take in energy, transform it, and release it. This is accomplished by chemical reactions. Chemical reactions in living things need to be very fast.
Enzymes are catalysts made by living things. They are almost always proteins. All cellular life uses enzymes to speed up chemical reactions. Enzymes lower activation energies and speed up chemical reactions in living things. Enzymes increase the speed of a reaction by decreasing the activation energy of the reaction. The energy of the reactants and the products is the same, but the activation energy is lowered by the enzyme.
Generally, you can recognize an enzyme by the ending ASE or ACE. Okay, so examples of some enzymes that you might be familiar with are the digestive enzymes lactase, amylase, or peptidase, and we'll spend the next several slides discussing these common enzymes. The first common enzyme we can talk about is lactase. Lactase helps us digest dairy products. The sugar that's found in dairy products is the disaccharide lactose. Okay? And what lactase does is break that lactose down into two monosaccharides. So right here we have lactose. Okay? And through the addition of water and the enzyme lactase, we break the sugar here, the lactose sugar here, and we end up with two monosaccharides, galactose and glucose. Maybe you've heard before of people that are lactose intolerant. A lactose intolerance just means that that person has trouble digesting dairy products because they stop producing the enzyme lactase. People who don't make lactase can take pills known as lactate pills that contain lactase before eating dairy products to help break them down. The second common enzyme we can discuss is the digestive enzyme amylase. Amylase is an enzyme found in human saliva that begins the process of breaking down carbohydrates or carbohydrate digestion in your mouth. What amylase does is breaks down that large starchy molecule into the disaccharide maltose.
Potatoes are starchy. Starch is made of many sugar molecules which are bound together. When you chew a potato, amylase breaks down the starch into smaller sugar molecules called maltose. It's part of digestion. Your body makes amylase. It would take years to break down starch without amylase. Peptidases are a family of enzymes that break down proteins into polypeptides and amino acids. Peptidases catalyze the hydrolysis reaction that breaks peptide bonds. Peptidase 1, an allergen found in dust mite feces that causes human allergies, is pictured here. Enzymes speed up biochemical reactions by providing a space called an active site for the substrates or reactants to bond. This decreases the activation energy required for the reaction by putting the substrates in the right position to have their bonds broken and then remade again to form the products. Keeping the substrates close together enables them to react quicker than if they were just randomly drifting through the environment. So pause the video here for just a minute, and you can click on the PDF to see a video on enzymes. Just as a key only opens a specific lock, each enzyme has its own unique shape, so each enzyme is specific to certain substrates. As the substrates enter the active site, which is here, it's labeled A1, the enzyme shape changes just a little in order to create a better fit for those two substrates, B1 and B2, and induced fit. When the substrates fit into the enzyme, it's called an enzyme-substrate complex. Their reaction takes place and the products leave the enzyme. So you can see that process down here. Here is that substrate entering the active site, and here it is fitting in, and that's that enzyme-substrate complex. Then the reaction occurs and the products leave that active site of the enzyme. And here's just another view of that enzyme function. So here you have those active sites ready for the substrates, and then they come here. The chemical reaction occurs, and then the products are released.